Okay guys, so what we're going to learn today is about the factor and remainder theorem, which is essentially the same thing and actually quite a very easy topic to grasp, I think. What this leads on to though is algebraic division, which can be quite confusing but also quite fun, I think, actually. So let's start off with what the factor and remainder theorem actually is. And the whole point of this, guys, is essentially at this stage you cannot factorize a cubic expression, for example, or a quartic, or the list can go on. You can't factorize them. At the moment you can be given, say, x plus 3, x minus 2 and x plus 1, f of x equals, and then the question could say draw that, and I'm sure you could, and then you could differentiate, etc., to find the max and mins, blah 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 blah. But if they started you off and said, well, sketch f of x equals 3x cubed plus 2x squared plus x minus 6, well, it would be very hard for you to know where to start. I mean, you could probably say where it crosses the y-axis, but that's about it, isn't it? Okay? So this is where the factor theorem comes in, the factor and remainder theorem. So first off, we need to know, like I say, what it is. So it states that if f of a equals 0, then x minus a is a factor of f of x. Okay, so let's see this actually work in practice, alright? So let's start with our f of x equals 3x cubed plus 2x squared plus x minus 6. So this was the example we started with in the first place, okay? So the question's saying, maybe the question will say, validate that, say, x minus 1 is a factor of this, okay? So let's do that. We're going to use our formula. So here, my a here must be 1, mustn't it? So if I put f of 1 equals, and I just replace all my x values by 1, I get this. And then if I whack that into a calculator, or I use my mind, I get 3 plus 2 plus 1 minus 6 equals 0. Therefore, I must write this in the exam. I must write this conclusive statement to get the full marks. There I say, therefore, x minus 1 is a factor of f of x. And this is because it equaled 0, didn't it? Or I could say the equivalent of, say, by the factor theorem, x minus 1 is a factor of f of x, or some equivalent of that, okay? Let's try another example. So, if we had f of x equals 2x cubed minus 8x squared plus x minus 1, and again it says, is x plus 2 a factor, for example. This time, remember, it says here minus a. So my a here must be x minus 2. So my a must be minus 2. So that's what I'm going to put in here. F of minus 2 equals 2 times minus 2 cubed minus 8 minus 2 squared plus minus 2 minus 1. And if I, again, work that out, this gives me minus 51. So, hence, or therefore, x plus 2 is not a factor of f of x, but in fact gives remainder minus 51, which is this number here, okay? So, if the number is not 0 when divided by the number here, by the term here, then whatever the answer is here, this is our remainder, okay? Let's try a final example then with the factor theorem, and I think by this point you're going to get it. So here we're going to have f of x equals a much larger order of x this time, so 5x to the 5 minus 2x to the 4 plus 3x cubed plus x squared minus 7x plus 1428. And again, the question's saying, is x plus 3 a factor, and if not, what remainder does it give? So again, my factor theorem says x minus a. Here I've got x plus 3, so therefore my a must be minus 3 for that to work, because, okay, x minus 3 would give me my x plus 3. So f of minus 3 equals 5 times minus 3 to the 5 minus 2 minus 3 to the 4 plus 3 minus 3 cubed plus minus 3 squared minus 7 minus 3 . So I have f of minus 3 equals 5 minus 3 to the 5 minus 2 minus 3 to the 4 plus 3 minus 3 cubed plus minus 3 all squared minus 7 times minus 3 plus 1428. Okay, so if I whack all that into a calculator, my answer is 0. So hence x plus 3 must be a factor of f of x. Now we're going to use what we've just learned and expand on it to actually fully factorize a cubic, for instance, okay, by taking our first example. So let's see that on the next slide. Okay guys, so what we're going to do now is we're going to fully factorize a function of x, okay, using what we know already. So let's take an example, f of x equals x cubed plus x squared minus 4x minus 4. The idea of this is I want to fully factorize it and then be able to draw this curve, which at the moment we can't do. Okay, so let's start by using the factor theorem. Okay, so at the moment the question is giving me this. So I can use trial and error to see which numbers, what I can divide this f of x by to give, to give us a factor. Okay, so if they don't give us, say, prove that x minus 1 is a factor or something like that, don't panic. Alright, in an exam you will be able to do this. They'll be nice to you, so it will be something like f of 1 or f of 2 or f of 3 or f of minus 1, f of minus 2, minus 3 or f of 0. Okay, they'll be nice. So I'm going to try f of minus 1. So this will be minus 1 cubed plus minus 1 squared minus 4 times minus 1 minus 4. And that will give me minus 1 plus 1 plus 4 minus 4, which equals 0. So hence x minus 1, well x plus 1, sorry, is a factor of f of x. Yeah? Just like before. So I know then that f of x equals x plus 1 times something in here, don't I? This massive bracket. So I know that this must equal this, and this thing in this massive bracket must be a quadratic, because here I've got x cubed and I've only got an x, so I need some form of x squared here, don't I, to get this x cubed. So this must be a quadratic. We're going to use algebraic division then to find out what that quadratic is. So this is going to look a bit alien at first, and I'm going to do another YouTube video of just examples for you to see how to do this. But just to introduce, what we do is we put what's called our divisor there, which is here, because we know that's a factor, and we're going to put f of x into here. So this looks very similar to regular long division, assuming you've seen this before at school. So we have this. And what we're going to do is we're going to do it step by step. So it's very mechanical, and once you've got it, you've got it, okay? So, how many times, or what is x cubed divided by x? Well, the answer is x squared, isn't it? So I put my x squared up here. I then immediately say minus bracket. So I'm going to times this by this whole bracket and expand it out inside. So I get x cubed here, because x squared times x is x cubed, plus x squared. Close bracket, always draw a line. Okay, so there I would have x cubed minus x cubed, which of course gives me 0x cubed. And this is the whole point. I'm gradually trying to eliminate all my orders of x, okay? Here I have x squared minus x squared, which gives me 0x squared. Okay, so here, what I do is I've only got one term, haven't I? So I need to bring down the next term, because I always need two terms to deal with. So I'm going to bring down the next term, minus 4x. And I repeat the process. So how many x's in 0x squared? Well, it's 0, isn't it? So plus 0x. Just like before, I'm going to take this number and multiply out this bracket. So minus bracket always. 0x times x is 0x squared. 0x plus 1, 0x, times plus 1 is plus 0x. Draw a line, always draw a line. Then 0x squared minus 0x squared is gone. Minus 4 minus 4x, minus 0x is minus 4x, isn't it? I've only got one term, I'm going to bring the next one down. So minus 4x minus 4. Minus bracket, as always. Do you see here I've eliminated all my orders of x squared? Now I'm going to do the same with my just regular x's. So, how many x's in minus 4x? Well, there's minus 4. And again, multiply out minus 4 times this bracket gives me minus 4x minus 4. Draw a line. And then we have, of course, minus 4x minus minus 4x is 0. Minus 4 minus minus 4 is 0. Okay? And that's what we wanted, because we knew that x plus 1 was a factor from the factor theorem. So if this was any other number, that would mean that is the remainder, but of course we don't have a remainder because it's a factor. So now I can draw this, write my f of x as being x plus 1, and my quadratic I was looking for was this one here, x squared minus 4. And then of course I could multiply this out, couldn't I? Difference of two squares. Do you see? This is the whole point. We've got to this point now, and now I could very easily draw a quick sketch of my f of x. I know my solutions for the x-axis are when y equals 0, so therefore it must go at minus 1, it must go at 2, and it must go at minus 2. My graph is obviously positive, it's a positive cubic. At x equals 0, my y must equal 1 times minus 2 is minus 2, times 2 is minus 4. So I know it crosses here at minus 4. And then I can very quickly draw my sketch. So let's do it. So it's going to look like something like that, isn't it? And there we go. Algebraic division. So guys, one final thing before I go. I do want to stress something here. So in advance I've done f of x equals 3x cubed plus 2x squared plus x minus 6 divided by x minus 1, which we found in the first slide was in fact a factor. So it makes sense that it gives a 0 remainder here. What I want to stress with you, and you can pause the tape and work all this stuff out if you want to, but remember there's going to be another example YouTube video coming up. What I want to stress is what the question asked for. So if the question wanted you to fully factorise, I would write my final answer as f of x equals x minus 1 times 3x squared plus 5x plus 6. But if the question asked you to divide f of x by x minus 1, I would have my final answer f of x divided by x minus 1 equals the thing in the brackets. Okay? Very important, the difference. The final thing is, imagine this wasn't 0 remainder and actually it was 7. Then actually my fully factorised would look like that, and my divided version would also have a remainder divided by x minus 1. Okay?